Okay, so think about this for a second. From those ancient myths about time repeating itself in these like huge cycles
Hmm.
to H.G. Wells just like launching us into the future with his time machine, and then of course Marty McFly just trying to get back to 1985.
Right.
Time travel has this like grip on us, you know?
Yeah,
It just won't let go. Makes you wonder, right?
definitely.
Could you, like even if it was just theoretically possible,
Mm.
could you actually go back and change something? And what would happen if you actually messed around with the past?
Hmm.
That's exactly what we're going to try to unpack today in this deep dive. So let's get right into it.
Yeah, it really is this fascinating thing because it's where our like hopes and dreams and stuff
Right.
sort of crash right into the laws of physics, right?
Exactly.
And what's so interesting is that while it always feels like it's just fantasy, right?
Right.
Modern physics actually gives us some possibilities to think about. So, for example, you've got Einstein's theory of relativity, right?
Mm.
That showed us that space and time aren't actually these separate things. They're not rigid. Instead, they're like kind of combined into this bendable thing. It's all one thing, space-time. And space-time can be warped, especially by things that have a lot of mass, like planets and stars.
Oh, okay. So Einstein gives us this whole picture of space-time being all bendy and flexible.
Mm.
And from that idea, there's this even crazier idea,
Right.
wormholes. So think of wormholes like, shortcuts, but not just shortcuts through space, but shortcuts through time, too.
Yeah.
Back in 1994, there's this physicist, Kip Thorne,
Mm.
and he really dug deep into this idea.
Yeah.
He thought that wormholes could, like, theoretically act as these time machines,
Exactly, yeah. But here's the thing. Keeping these wormholes open, like keeping these time tunnels open and stable is not simple. It's not easy.
Right, yeah.
Thorne's research showed that you'd need this thing called exotic matter.
Exotic matter.
Yeah. And this is not the stuff that we see every day.
Right, right.
It's this hypothetical kind of matter. And the crazy thing about it is that it has negative energy density.
Negative energy density.
Yeah. So imagine, like, it's the opposite of gravity.
Yeah,
So
no.
instead of pulling things in, it pushes them away. It's pretty wild.
Wow. Okay, so we need this, like, anti-gravity stuff to hold open this time doorway.
Right.
Right, that makes sense, like, in a sci-fi way, but,
Yeah.
the moment you even start to picture yourself stepping through this doorway, right, you bump right into the grandfather paradox.
Yeah.
And this one, it's like a real head-scratcher.
Yeah.
So imagine you go back in time and you somehow stop your grandparents from ever even meeting.
Right.
That means that logically you would never have been born, right?
Yeah.
But if you were never born, then who went back in time to stop your grandparents from meeting in the first place?
Exactly. Yeah.
It's like this crazy loop where it just cancels itself out.
Yeah.
So what's really unsettling about the grandfather paradox, isn't just this crazy logical loop, but it makes us question this basic idea of cause and effect, right? Like we think of cause and effect as a straight line, one thing leads to another. But this paradox throws that whole idea out the window. It's like the universe is telling us, hey, there are rules here, buddy. You can't just mess with things however you want.
Right.
It's hinting at something much more complicated and interconnected than we usually realize. So back in 2002, there's this physicist, Dr. Igor Novikov. He thought about how to make sense of all this.
Yeah.
And he came up with this idea called the self-consistency principle. So what he's basically saying is that the universe has this built-in way of protecting its timeline, right?
Yeah.
Like a safeguard. So anything you do in the past, even if it seems like a big change to you, it has to already be a part of history.
Yeah.
You couldn't actually do something that completely unravels your own existence.
Yeah.
Like the past is sort of resistant to these big drastic changes from time travelers.
Right. Yeah.
So no going back and buying a winning lottery ticket before the numbers are drawn, huh? It seems like the universe has that one covered. But wait, there's this other really wild idea, right? And it might offer a way around this paradox. What about that many worlds interpretation? I think it comes from quantum mechanics, right?
Yeah. Yeah. You're exactly right. So the many worlds interpretation, it gives us a completely different and super radical way to think about the grandfather paradox, right? Instead of there being just one timeline, one fixed set of events,
Right.
this interpretation says that every single time there's a quantum event and there are multiple possible outcomes,
Okay.
reality actually splits.
It splits.
Yeah, it creates these parallel universes, and each universe represents a different outcome of that event.
Wow.
So imagine you go back in time and you make a change. What you're actually doing is you're not changing your original timeline.
Right.
You're branching off into a new separate reality where that change happened.
Mm-hmm.
But your original past, and therefore you, in that original timeline, would remain completely untouched.
So there could be an infinite number of these like coexisting histories, all a little bit different from each other.
Exactly, yeah. Yeah, it's a pretty wild thought.
Yeah, that's a lot to wrap your head around. Infinite branching realities.
It is.
Okay, well, let's move on to another classic time travel brain teaser, shall we?
Sure.
The bootstrap paradox. Now, this one always makes me think of that old question, which came first, the chicken or the egg? It's like that. So imagine this scenario, right? You travel back in time, and you give a young Mozart, like before he's famous, you give him all the sheet music for all his amazing symphonies that he's going to write in the future, right? And he studies them, maybe even copies them, and then he goes on to compose them. So who's the real composer in this situation?
Right. That's it. That's the bootstrap paradox right there.
Yeah.
You've got an object or information, in this case, the music, right?
Yeah.
And it just exists. There's no clear origin. It's like it was bootstrapped into existence through this time loop. You see these kinds of examples in fiction a lot, like Doctor Who, for example. They have these objects or ideas that just keep cycling through time. You can never find the beginning.
It's like trying to find the beginning of a circle, right?
Exactly.
Yeah, it just goes round and around.
Yeah.
It really challenges how we think about cause and effect. And speaking of cause and effect, there's Dr. Seth Lloyd, and he's been looking into these ideas through the lens of something called closed timelike curves.
Yeah, closed timelike curves. Those are like loops in the fabric of space-time, right?
Right.
And what's really interesting to think about is that these closed timelike curves, these loops, they might actually allow for these self-consistent time travel scenarios.
Okay.
And that could include the bootstrap paradox that we were just talking about, you know?
Right.
Like information or even physical objects, they might just loop back on themselves through time, and it wouldn't necessarily create a contradiction within that loop. However, as Dr. Lloyd and some other physicists have pointed out, these loops, just the fact that they could exist, creates other problems.
Right.
It's when we try to fit them into the bigger picture of the universe, like they don't really make sense with our usual ideas of how cause and effect work outside of the loop. So even though things might be consistent inside the loop, it could still clash with the rest of reality, you know, like the reality that you and I experience.
So this has all been super interesting, all this theoretical stuff.
Right.
But it is very abstract. So has there been any evidence, like in the real world, even something small, that shows that time isn't as simple as we think it is?
Yeah.
I remember hearing about some experiments with clocks on airplanes.
Oh, yes. That's right. So even though we haven't built a time machine to send us back to the dinosaurs just yet, we do have these experiments with time dilation. This comes straight from Einstein's theory of relativity, and we've proven it with experiments. And these experiments show that time isn't this absolute thing, this constant thing that's the same everywhere.
Okay.
It's not like that. So in this famous experiment, they took these super, super accurate atomic clocks, and they flew them around the world on commercial airplanes. They flew them in opposite directions, and then they compared them to identical clocks that stayed on the ground, and the results were amazing. The clocks that were moving, they showed a tiny, tiny but measurable difference in how much time had passed compared to the clocks that were on the ground.
Really?
Yeah. The clocks that flew eastward, you know, in the same direction as the Earth's rotation, they actually lost a tiny fraction of a second. And the ones that flew westward, they gained a tiny fraction of a second, all compared to the clocks on the ground.
That's incredible. So moving faster or slower actually changes how time passes for you. That's mind-blowing when you think about it, like in everyday life, you know. But like you said, a tiny fraction of a second for an atomic clock, that's not going to let us travel back in time and watch historical events, right?
Exactly. So human time travel, like we see in movies, it's still just speculation at this point.
Right.
But scientists are still exploring some pretty radical ideas. For example, there's Dr. Ronald Mallet.
Okay.
He's got these ideas involving lasers, rotating lasers, actually.
Hold on. Rotating lasers that create time loops. That sounds like something straight out of a movie.
I know, right? It sounds crazy.
Yeah.
But it's based on real physics. you know?
Yeah.
Dr. Mallett's idea is that if you had these lasers, these super powerful lasers that were configured in a very specific way and you got them rotating,
Right.
they could create these incredibly strong gravitational fields.
Hmm.
And these fields, he thinks, might be able to twist and warp space-time so much that you could actually create a closed time-like curve, a time loop.
Wow.
But it's important to remember, these are just ideas. Like, we're nowhere near being able to do this kind of experiment. The energy you'd need, the technology, it's just way beyond what we have right now.
Right.
But it's a cool glimpse into what might be possible, right?
Yeah, definitely.
Way in the future. Who knows?
So let's just imagine for a minute that we could actually build a time machine.
Right.
That brings up a whole bunch of ethical questions, right? Like, should we even be allowed to change the past if we could? I mean, is that something humanity should be messing with?
Yeah, these are huge ethical questions, no doubt.
Yeah.
If time travel ever became a reality, would we be smart enough, responsible enough to handle that kind of power? It's almost impossible to imagine how many ways things could go wrong.
Right.
You could make what seems like a small change in the past, and it could trigger all these crazy ripple effects.
Yeah.
You never know what could happen.
Right, the butterfly effect, right.
Exactly.
But on a huge scale.
Yeah, cosmic scale.
And then you have to think about all the practical stuff,
Yeah.
right? Would we need some kind of time travel police?
Right.
Or would time travel just be completely banned,
Yeah.
just to protect the timeline?
Those are important questions. Who would decide what changes are okay and what changes aren't okay? What could we do to stop people from, like, abusing time travel?
Right.
To stop them from changing history just to benefit themselves?
Yeah.
And then there's this other really interesting thought, and it's maybe a little bit scary. What if time travel is already possible? I mean, in the future.
Okay. Yeah.
What if there are already time travelers out there and are watching us right now? What if they're making little changes that we don't even notice, just to make sure their timeline stays intact?
Makes you wonder, right?
It does. It makes you look at things a little differently.
So as we wrap up this deep dive, we're left with a big question, aren't we?
Yeah.
Is time travel just a fantasy?
Right.
Will it always be something we can only dream about? Or is it something more, something that could be dangerous, something we should maybe be afraid of?
What's really thought-provoking is that the more we learn about time travel, the more we realize how deeply it's connected to everything, to the universe, to how it works, to our own existence even.
Yeah.
And as science keeps advancing, what we think is impossible today might be totally normal tomorrow, right? We can't even imagine what the future holds.
It definitely gives you a lot to think about.
Yeah.
So remember that self-consistency principle we talked about. What if those deja vu moments, those times when you feel like you've already experienced something before, what if those are actually little glimpses of other timelines? Or if the many worlds interpretation is true,
Right.
I mean, that means every choice we make creates a whole new universe.
Right.
So
Yeah.
our choices have a lot more weight than we realize, maybe. It's a lot to ponder. Keep thinking about all this stuff. Until next time, folks.
Yeah, keep those questions coming.
Take care.
See ya.